Hello, ladies and gentlemen, and welcome back to more of the 2009 Cayley contest. And we're on question 21 now. A lattice point is a point with integer coordinates. For example, 1/4 is a lattice point, but 3/2 4 is not, because 3/2 is not an integer. That's all it takes, just one of them being not an integer, it's not a lattice point. The line y equals 3x minus 5 passes through square PQRS as shown in the diagram. Oh yeah, it really does. Okay. If the coordinates of R are 2009, 2009, and we're being told this is a square, okay, so I think they mean for P to be the origin. It's not entirely obvious. But, you know, what else could they really mean here? So if the coordinates of R are 2009, 2009, then the number of lattice points on the line which are inside the square is. Okay. So we don't have a lot of problems here in terms of finding lattice points on the line. As long as x is an integer, 3x minus 5 will be an integer. So you just need to make x an integer. And if y were an integer, you need to add 5. Well, no, any x integer value, you need to have x be an integer to be a lattice point. That's not all you need. But as soon as x is an integer, y is also an integer. So that's not really going to be a problem. So we can just count the number of x's that give us points inside the square. But that's the challenge. So the square here constrains us both in the x coordinates that we can put in and the y coordinates that we can get out. And this is going to lead us to two, I think, inequalities. Okay, so for a lattice point, I'll call it xy on the line, x is an integer, 3x minus 5 equals y is also an integer. So we're fine there. The question would be different, for example, if it was 3/2 x minus 5, because then only certain integer values of x will give us integer values of y. This is why I'm bothering to point this out. Okay, but because it's multiplying integers and then subtracting another one, we don't have to worry. Okay, so if this is on a line, we're fine. X just needs to be an integer. Okay, and if it's inside PQRS, then I'm going to say 0 is less than x is less than 2009. And we also have y must be in this range as well. Okay? Because that's what these bounding lines out here are. This is the line x equals 2009, can't go further than that. And this is y is 2009, can't go beyond that. Okay. Well, the x values, this limits us to 1, 2, 3, all the way up to 2008. So that's 2008 possible integers. But it's the y values that we really have to pay attention to. So we get a second inequality here. But since y can be expressed in terms of x, we actually now have 3x minus 5 less than 2009. So 5 has to be less than 3x, which has to be less than 2014. And dividing those by 3, we're going to have 5 divided by 3, 1.6 something. And 2014, I'm pretty sure, is also not a multiple of 3. Nope. 671.33, it doesn't really matter. Okay, but what does this actually tell me? Well, the values of x have to be between 2 and 671 inclusive. If it was a little bigger, it would be 672, and that wouldn't be allowed. If it was less than 2, it would have to be 1, and that's not allowed, because that's less than 1.6. Okay, so how many numbers are there between 671 and 2? Well, if I'm counting all the numbers between, let's change this to an m. So if I've got m and n, and I want to know all the integers between m and n, and including m and n, there's a nice little formula you can know. N minus m plus 1. So in this case, 671 minus 2 plus 1 is going to be 670. Okay? Those 670 numbers, 2, 3, 4, all the way up to 671. Okay, and is that one of the answers? It is. It's E, which is the biggest answer. And, it makes me think maybe I should double-check my arithmetic for a moment. Double-check this formula as well. Okay. Now, I've used less than signs. What if I were using less than or equal signs? Would that change a whole heck of a lot? No, because we didn't get integer values here either, so I'm not missing anything out. 6, 7, 1 works just fine. As for my formula down here, I'll just give it a quick double check. So between 2 and 5 inclusive, I should have 2, 3, 4, and 5. That's 4 numbers. 5 minus 2 is 3, plus 1 is 4. Okay, I'm a little more confident in my answer of E. Alright, so that finishes up question number 21. Up next, of course, question number 22. I'll see you there.